So now our rational functions can have vertical asymptotes, but they can also have horizontal asymptotes. So they can have places on the graph that y can't equal a number. These ones actually require less math than your vertical asymptotes, and you can get these answers by just looking physically at the equation. You just have to remember 3 specific rules. So when we talk about horizontal asymptotes, these are our y equals lines. They're things y cannot equal. So we're going to have equations where it's y equals some kind of number. And remember, an asymptote is an imaginary line on the graph that your graph cannot cross. So these y values are going to be y values that don't show up in your graph. So because they don't show up in your graph, they make an asymptote. So our first rule says that if the degree, and remember degree is your biggest exponent, of the numerator equals the degree of the denominator, so if the degrees are the same, so like in the example how the biggest exponent is 2 in both the top and the bottom, then you take the leading coefficients, and that is your asymptote. Then the asymptote is at the leading coefficients. So if we're looking at this first one, since the degree here of 3x squared plus 1 over 4x squared minus x plus 5, so they both have a degree of 2, all we're going to do is take their leading coefficients, which remember leading coefficients are the coefficients in front of the biggest exponent. So my asymptote, my horizontal asymptote here, will be y equals 3 over 4. So if the degrees are the same, you just take that leading coefficient, and that's your answer. Easy, right? Eric's favorite kind of math where you just have to look at it. So if they're not equal, we have 2 other situations. If the degree of the numerator is smaller than the degree of the denominator, so degree numerator less than degree denominator, then the asymptote, the horizontal asymptote, will always be y equals 0. So if the bottom is bigger, the answer is automatically y equals 0. So there's even less work to do there. You don't even have to pick out any numbers. You just have to say, okay, the degree in the denominator is bigger. So the horizontal asymptote if you're looking to abbreviate asymptote because it's a very long word, you can go ASYM. going to be y equals 0. So because my degree in my denominator is a 2, my degree in my numerator is a 1, my asymptote's at 0. So degrees are the same. Take the leading coefficient. Bottom's bigger, 0. If the top is bigger, there's no asymptote at all. So my last situation, if the degree of the numerator bigger than the degree of the denominator, then no horizontal asymptote. So if you were looking at something like 3x squared minus 1 over 2x minus 1, there is no horizontal asymptote there because the degree, the biggest exponent in the numerator is a 2, the biggest exponent in the denominator is a 1. So because the top is bigger, there is no horizontal asymptote. So the one thing you do need to pay attention to is when we were finding vertical asymptotes, we wanted to factor it and see if there was anything we can cancel out. If the question asks you to identify the horizontal and the vertical factors, asymptotes, you want to make sure that you find the horizontal ones before you factor, because you need to know the degrees, and once you factor, you're not going to see that degree. So you always want to find your horizontal ones first if they ask you for both. So find the horizontal before you factor, because you need that unfactored form in order to look at the degrees. Does that make sense? Okay. So your classwork and homework today is going to look like this. It's going to say something like, find the vertical and horizontal asymptotes of f of x equals 2x plus 1 over x squared minus 1, and state the domain. So before we find the vertical, we want to make sure we find the horizontal. Because before I go and start factoring this and simplifying it, I want to see if there are any horizontal asymptotes. So my horizontal asymptote, I need to look at my degrees. I see that my degree here is a 1, right? There's no exponent. The bottom is a 2. So the bottom is bigger. Where is my asymptote? Y equals 0. So my horizontal asymptotes are always going to be y equals. My vertical asymptotes are going to be x equals. Because now for my vertical asymptote, I need to take my denominator of my factored form and set it equal to 0. So if I take 2x plus 1, there's nothing I can factor there, but I know x squared minus 1 is really x plus 1, x minus 1. There's nothing I can cancel, so I'm just going to do x plus 1 equals 0 and x minus 1 equals 0, because I want to set my factors in my denominator equal to 0 after I've seen if I can cancel anything. So then I subtract 1 here, I add 1 here, get x equals -1, x equals +1. So my vertical asymptotes are at x equals positive and -1. And then the last thing it wanted to know was my domain. And remember, domain is just our fancy math vocabulary word for x values. So you could take two routes here. You could give me the domain in interval form and tell me it's everything from negative infinity to negative 1 to 1, 1 to infinity. Or you could say, hey, I've got all the x values except for x cannot equal positive or negative 1. So you can also take that route. Or you can go negative infinity to negative 1, negative 1, 1, and 1 to infinity. They mean the same thing. We can't have negative 1, we can't have positive 1. So you can use the fancy math symbol, the equal sign with a line through it that says cannot equal positive or negative 1, or you can give us the intervals like we did back in